So today, my dear students, we are going to start with the next chapter, that is the hydroxy compounds. Okay, ji? So last time we finished with the methyl benzene, okay, and we did some of the past paper questions. So today we are going to start with the hydroxy compounds. So hydro, the third chapter. Yeah, oxy compounds. So in the hydroxy compounds, the first thing you should know that is the triidomethane test, which you people have done it in your A1s, but I'm going to repeat that one for you because this is also present in that chapter. Okay, so let me repeat it for you. The first one, that is the triidomethane test. Triidomethane test. So this test is also called as the iodoform test. Okay, so try iodomethane test, or this test is also called as the iodoform test. So what is this test and how we are going to apply this test? Have a look up here. If you got this group CH3 and C double bond O, and the next chain is continuing. Okay, and this group should be present only in aldehyde and ketone, nothing else. Aldehyde and ketone. Okay. Let's suppose if this group is present in the carboxylic acid, this test couldn't be applied on it. This test could only be employed when you got aldehyde and ketone and this group is present. Okay. The second one, that is CH3, COH, and H, and the next chain is continued. So this one is the alcoholic group. Okay, so try iodomethane test that could only be used for aldehyde, ketone, and alcohol, nothing else. If the compound is carboxylic acid and this group is present, no test could be used. If the compound is ester, this group is present, no positive test for that. Okay, if the compound that is acyl chloride and this group is present, so no positive test for that. So this test is only positive when the compounds they are aldehyde, ketone, or alcohol. Keep remember that. Okay. What are the reagents used for this test? The reagents used for this test, there are two. The first one, that is sodium hydroxide aqueous and iodine aqueous. So it could be written like that. And in some papers, he write it as alkaline aqueous iodine. So this is the second thing. And the third thing, that is OH minus aqueous and I2 aqueous. Okay. So all these things meaning same. NaOH is alkali. NaOH is represented by OH minus. So iodine is coming in all these. So all these things, they represent the triidomethane test. These are the reagents for triidomethane test. Okay. So now, my dear students, what would happen in that test? Okay. So in that test, what should you do? You should take a test tube like that. Okay. Put some amount of the sample whom you want to analyze. So this is the sample. Okay. Put aqueous iodine in it. So aqueous iodine. Aqueous iodine is brown in color. Okay. So make the whole solution as brown. Firstly, it would become brown. And then what should you do? You should add sodium hydroxide in it drop by drop. Drop by drop. And when you add drop by drop sodium hydroxide in it, so what would happen, guys? This whole thing will form a precipitate of yellow color. So a yellow precipitate that is formed. Yellow precipitate. Okay, so this yellow precipitate that is CHI3. CHI3 that is called as the triidomethane. Okay, so this is of triiodomethane. Okay, and when it is being formed, when you got this group in aldehyde and ketone, and this group in alcohol. So keep remember again, this test could only be used for aldehyde, ketone, and alcohols. Not on carboxylic acid, not on acyl chloride, not on esters, nothing else. Only aldehyde and ketone. Okay, and alcohol. Okay, so this yellow precipitate would be formed if this group or this group is present in the sample. Okay, now what would happen basically? Let's suppose if I got a compound CH3, C double bond O, CH2, and CH3. Let's make this one as a simple one, not like that. Let's make it simple. Benzene, okay, and this group is present like that. Okay, so if you look up here, this is C double bond O, and it is surrounded by the carbon up here and carbon up here. So this is my dear ketone. Okay, and it got CH3. This is CH3, and this is C double bond O. Okay, so this group is present. Okay, it means we can use the triiodomethane test. So in that test, my dear, you should take the iodine aqueous and you should take the NaOH aqueous. Okay, so what would happen, Rita? The method is very simple. So you should break this one from here. Sorry, break this one from here. Okay, now this thing, write it separate. Benzene, okay, and C double bond O. Okay, and this CH3 would join with the iodine to form CHI3. This is forming the yellow precipitate, and this one that is the triiodomethane. Triiodomethane. Okay. Now this thing remaining, it would join with the ONA. So O minus Na positive. So this is the salt of carboxylic acid. This is the salt of carboxylic acid. So this salt has been derived from the carboxylic acid. Okay. So you should break this one from here. This CH3, it would join with iodine to form CHI3, and this whole thing that would have joined with the ONA. Okay. So this would be the salt of carboxylic acid, and second thing formed, that is the triiodomethane, that is of yellow precipitate, yellow color precipitate solid particles. Okay. Okay, guys. सो हाइड्रोक्सी कंपाउंड में हम लोग पहला टॉपिक जो है वो डिस्कस करने जा रहे हैं. सो लेट्स स्टार्ट विद द फर्स्ट टॉपिक ऑफ दिस चैप्टर, दैट इज द फिनोल. What is the phenol? When we have done the naming, I told you with the benzene, if the OH group is attached directly like that. Okay, so this is called as the phenol. Okay, this is the phenol. And in paper, if sometime they ask you that what does this group mean, so don't say it's the alcoholic group or don't say it's the hydroxy group. It is the phenolic group. Keep remember that. Okay. Now listen about the phenol. What is phenol? Phenol is actually a weak acid. Okay. So before starting the phenol, okay, but first of all, I'm telling you about the phenol. Phenol is a weak acid. Why it is a weak acid, my dear? Have a look up here. I'm going to draw this O and H up here. Okay. Now, you know that I told you last time, when any element attached with the benzene ring directly, having the lone pair of electron, so what does it do? It delocalizes its lone pair to the benzene ring. Okay. So when it delocalizes its lone pair to the benzene ring, oxygen has got the shortage of electron. When it got the shortage of electron, so this bond is already polar. This is partial positive and this one is partial negative. This is already polar. What does it mean? This polarity means, let's suppose firstly the polarity is negative 0.2 and positive 0.2. Let's suppose. Okay, it's like that. But when this oxygen has delocalized its lone pair to the benzene ring, oxygen has the shortage of electron. So what does it do? It is going to attract the electrons from hydrogen towards itself more, and the polarity that is going to increase. So polarity would become, let's suppose, negative 0.7, positive 0.7. So the polarity on the OH bond that would increase. So oxygen has delocalized its lone pair to the benzene ring. ऑक्सीजन के पास इलेक्ट्रॉन कम हो गए हैं. So जब ऑक्सीजन के पास इलेक्ट्रॉन कम हो गए हैं, what does it do? It is going to attract the electrons from the hydrogen towards itself. O and H bond is already polar. ये पहले से पोलर था. ऑक्सीजन ने पहले ही हाइड्रोजन के इलेक्ट्रॉन अपनी तरफ ज्यादा अट्रैक्ट किए हुए थे. बट आफ्टर गिविंग दिस lone pair to the benzene, इसका बस इसी हाइड्रोजन पे चलता है, इसके इलेक्ट्रॉन और ज्यादा अपनी तरफ अट्रैक्ट करता है और पोलैरिटी बढ़ जाती है. जब पोलैरिटी बढ़ जाए तो बॉन्ड वीक हो जाता है. इसकी एग्जांपल ऐसे ले लें, माय फ्रेंड बट एंड मी, वी हैड अ बुक इन शेयरिंग. He got 200 rupees, I got 200 rupees. That book was worth of 400 rupees. And we both decided to keep that book for me for 2 days and for him 2 days. Okay, that was pre-decided. But when we have taken the book and that book was given to me, I'm going to keep it for 3.5 days and I'm going to give him for half a day. Okay, now he's weak. He says, "Sir, what are you doing?" I said, "Come on, shut up and just keep it." I'm just saying you because oxygen is strong, man. Hydrogen is very weak. So what does the oxygen do? It keeps the shared electron of oxygen and hydrogen towards itself more. So we're getting the partial negative and partial positive charge more. Okay, the polarity that is going to increase. Firstly, the polarity is this one when it has not delocalized its electron. But when it delocalized electron, it got the shortage of electron. It is going to attract the electrons towards itself from the hydrogen. The polarity of OH bond would increase, resulting in the weakening of OH bond. और जब वीक बॉन्ड हो जाएगा तो बट साहब को अगर हाफ डे के लिए बुक मिलेगी तो कल को इसका मेरे ऊपर बस भी नहीं चल रहा. सो व्हाट ही इज गोइंग टू डू, ये कहेगा ये ना भाई 4 दिन तू रख, ठीक है. ये किसी और के साथ जाकर उसकी मिलते करके कहेगा यार शेयरिंग में दे दो, मैं तो गलती कर बैठा हूं. तो ये बॉन्ड यहां से टूट जाएगा और H पॉजिटिव आयन प्रोड्यूस करेगा. और कीप रिमेंबर व्हेन एनीथिंग प्रोड्यूसेस H पॉजिटिव आयंस इन इट्स एक्वस सॉल्यूशन, दैट इज कॉल्ड एज द एसिड. तो फिनोल जो है ये वीक एसिड होता है और इसको अगर वाटर में डिसॉल्व करें तो ये हाइड्रोजन आयन प्रोड्यूस करता है और इस एसिड को हम कहते हैं कार्बोलिक एसिड. कार्बोलिक एसिड. डिड यू गेट इट? तो फिनोल दैट इज अ वीक एसिड. एंड व्हाई? बिकॉज बेंजीन इज एन इलेक्ट्रॉन विथड्रॉइंग ग्रुप. ये इलेक्ट्रॉन इससे विथड्रॉ करता है इसका लॉन्ग पेयर. Benzene is electron withdrawing group, due to which the polarity of OH bond would increase, resulting in the weakening of OH bond, and hydrogen ions are donated when dissolved in water. So that is why it's a weak acid, and its aqueous solution that is called as the carbonic acid. Did you get it, guys? Okay, so just note it down now. Phenol is a weak acid and its aqueous solution is called carbonic acid. In phenol, the benzene group is an electron withdrawing group, due to which the polarity of OH bond increases, resulting in the weakening of OH bond, and H positive ions are donated when dissolved in water, causing acidity. Okay, guys. So phenol, my dear students, it's a weak acid, and its aqueous solution is called as the carbolic acid. And what is the reason behind it? Because benzene is an electron withdrawing group. I told you any element having the lone pair delocalized its lone pair to the benzene link. So it means benzene is actually the electron withdrawing group, due to which the oxygen has the shortage of electrons. So oxygen will attract the electrons from hydrogen. The polarity of OH bond that would increase, resulting in the weakening of OH bond, and H positive ions are produced when dissolved in water, causing the acidity. Did you get it? Now, everybody just listen. We are going to discuss the strength of different acids. Okay. So you should know their reactions. Okay. This is the general thing. If this thing in your mind, then you can do all type of the reactions. Okay. So everybody just look up here. We are going to discuss the strength of acids. Okay. So in nature, we got 5 substances which are acting as the acid. Okay. So the first of them, my dear, that is the mineral acid. Mineral acid is the strongest one. What is meant by mineral acid? Like hydrochloric acid, like nitric acid, like sulfuric acid. So all these are the mineral acids. So they are very strong acids. Okay. And then the second thing, that is the carboxylic acid. Carboxylic acid, you know that carboxylic acid contains COOH. Okay. So the first strong acid is mineral acid, then carboxylic acid. It is little bit less, it is weaker than the mineral acid. Okay. And then you got the phenol. Phenol is the third one on strength. And then after phenol, we got the water. Water is also the weak acid, very weak acid. And then comes towards the alcohol. Alcohol is very weakest acid. So anything that donates protons or H positive ions in its aqueous solution, that is acting as an acid. Okay. So the most strong of all these acids, that is the mineral acid, and the weakest acid, that is the alcohol. Okay. Now one more thing. Keep remember the acids, they could react with the 4 substances. The first substance, that is the metal. The second substance, my dear, that is the metal oxide. The third substance, that is the metal hydroxide. Hydroxide. And the fourth thing, that is the metal carbonate. So these are the 4 substances which could react with the acid. Mineral acids, they are very strong. They can react with all these 4 substances very easily. Okay. Carboxylic acid, they are a little bit weaker than the mineral acid, but it can react with these 4 substances easily. Okay. Phenol, my dear students, that is little bit weak. It could react with only 3 substances: metal, metal oxide, and metal hydroxide. Okay. So 1, 2, and 3. It could react, but with metal carbonate, with the fourth thing, it is unable to react. Okay, and the last thing, my dear, water and alcohol, they are aqueous acid, so they can react with the metal only. Okay, so they are unable to react with 2, 3, and 4. This is 2, 3, and 4. Okay. Oh, sorry. This one is cross. I'm sorry. Okay. So water and alcohol, they could only react with the metals. They are unable to react with metal oxide, metal hydroxide, and metal carbonate. Okay. Now, if you want to, if you are being given the 5 beakers, like beaker 1, 2, 3, or A, B, C. So this is A, this is B, this is C, D, and E. So these are the 5 beakers, my dear. Okay. So all of them, they contain the different acid. Like one of the beaker contain mineral acid, one of them contain carboxylic acid, one of them contain phenol, one of them got alcohol, one of them got water. Okay, and you want to differentiate them. So the method is very simple. In the first step, what should you do? So this thing looks very simple, but this thing is very important. Keep remember that. Okay, phenol could only react with metal, metal oxide, and metal hydroxide. If you got any metal carbonate like sodium carbonate, phenol is unable to react with it. Okay, so anyways, let's start. How could we differentiate them? In the step one, what should you do? You should take any metal carbonate, add metal carbonate. You can take any metal carbonate like sodium carbonate, calcium carbonate, that's your choice. Okay, in all 5 beakers A, B, C, D, and E. Okay, now the next thing, if you find the effervescence scene. Effervescence word is used if you got a bottle of Coke or 7 Up, and if you just shake it and then open it, so what would happen? The bubbles would start coming, okay, out. Okay, so those bubbles, that is actually the effervescence, and that is due to carbon dioxide. Carbon dioxide. So if effervescence is seen, so that thing, because metal carbonate, they could only react with mineral acid and carboxylic acid. Let's suppose B and D, they got the effervescence. Okay, so B and D, they got the effervescence. It means one of them is carboxylic acid, the other that could be mineral acid. Okay, now if you want to separate them, so this first step is still continue. Okay, in the next step, what should you do? Add alcohol in B and D. Okay, if fruity smell, fruity smell is due to ester formation. Okay, and only carboxylic acid, they form the ester with the alcohol. If fruity smell, so it means that could be the carboxylic acid. Let's suppose the fruity smell is with D, so D is carboxylic acid, and B, that could be mineral acid. Did you get it? Like fruity smell ester? Yeah, fruity smell, फ्रूटी स्मेल अच्छी स्मेल जो होती है वो एस्टर की होती है। वो एस्टर कैसे बनता है? कार्बोक्सिलिक एसिड और अल्कोहल के ज्वाइन करने से। ओके, ओके, नाउ कम टुवर्ड्स द स्टेप 2। आपके मिनरल एसिड और कार्बोक्सिलिक एसिड तो निकल चुके हैं। अब आपके पास three beakers बचे हैं. One of them contain the phenol, one of them contain the water, and one of them contain the alcohol. Now what you think? What should we do? हम लोग क्या करेंगे? फिनोल को चेक करें. फिनोल को रिएक्ट विद metal oxide and metal hydroxide, whereas water and alcohol they are unable to react with them. तो हम लोग क्या करेंगे? कुछ सॉलिड मेटल ऑक्साइड ले लेंगे, कॉपर ऑक्साइड. फिर इन तीनों में से कुछ भी ले सकते हैं. नहीं, तीनों में से नहीं, मेटल ऑक्साइड और मेटल, क्योंकि मेटल तो इन दोनों के साथ भी रिएक्ट कर सकती है. तो वी ओनली हैव टू टेक अ थिंग व्हिच इज able to react with phenol but not with water and alcohol. Okay, so add any solid metal oxide in beaker A, C and E. ठीक है जी. जहां पे वो सॉलिड मेटल डिसॉल्व होनी शुरू हो जाए, ओके, इट स्टार्ट डिसॉल्विंग, इट मींस वहां पे रिएक्शन हो रहा है. और जहां पे वो डिसॉल्व नहीं होती, इसका मतलब है वहां पे रिएक्शन नहीं हो रहा. ठीक है जी. सो add solid metal oxide in A, C and E. Okay, so this is the first step. If metal oxide dissolves, okay, so if metal oxide dissolves, let's suppose it dissolves in E. So E could be, my dear, phenol. And whereas ये E भी कट गया आपका, अब आपके पास A और C बचे हैं. A और C में मेटल ऑक्साइड डिसॉल्व नहीं है, तो वो आपके वाटर या अल्कोहल हो सकते हैं. नाउ माय डियर, द लास्ट स्टेप, आपके पास वाटर और अल्कोहल बचे हुए हैं. तो उसका बहुत आसान तरीका है भाई, स्टेप 3. ठीक है जी. स्टेप 3 में आप क्या करेंगे कि ऐड कार्बोक्सिलिक एसिड इन A एंड C. ठीक है जी. ए और सी में कार्बोक्सिलिक एसिड डाल दें. इफ इट वुड बी अल्कोहल, और तो अल्कोहल और कार्बोक्सिलिक एसिड जब मिलेंगे तो फ्रूटी स्मेल आना शुरू हो जाएगी भाई, अगेन एस्टर फॉर्मेशन. ठीक है. अगर फ्रूटी स्मेल नहीं आती तो इसका मतलब है दैट वुड बी वाटर. ओके, सो ऐड कार्बोक्सिलिक एसिड इन ए एंड सी. कोई भी कार्बोक्सिलिक एसिड आप लोग ये वाला नहीं उठाएंगे, यहाँ पे जो है कोई नोड एथेनोइक एसिड, प्रोपानोइक एसिड. ठीक है जी. इफ फ्रूटी स्मेल, और वो फ्रूटी स्मेल मैंने पहले ही बताया एस्टर की होती है सर, एफर्वेसेंस वाला नहीं है. नहीं, इसमें एफर्वेसेंस कहां से आ गया भाई? ठीक है जी. तो दैट वुड बी कार्बोक्स, दैट वुड बी अल्कोहल. सपोज करें वो ए में होती है, तो ए जो है वो आपका अल्कोहल है, और आपका पीछे बचता है सी. सी जो है वो वाटर होगा. तो इस तरीके से यू कैन सेपरेट दीज 5 एसिड्स. अब बिकॉज वी पीपल आर स्टडिंग द ऑर्गेनिक केमिस्ट्री, ऑर्गेनिक केमिस्ट्री में मिनरल एसिड का कोई काम नहीं है. ठीक है. तो आपको सिर्फ इन चीजों का पता होना चाहिए कि ऑर्गेनिक एसिड्स में से कार्बोक्सिलिक एसिड सबसे स्ट्रॉन्ग है, देन फिनोल, देन वाटर एंड देन अल्कोहल. इसकी बाकी तफसील जो है वो इंशाल्लाह ताला हम लोग कल स्टार्ट करेंगे. ठीक है जी. सो यू शुड नो, ये छोटा सा जो एक मैंने ग्राफ बनाया है, दिस इज वेरी इंपॉर्टेंट. रिएक्शंस में ये ग्राफ आपको बहुत हेल्प करेगा. ओके, सो यू शुड मेमोराइज दिस वन. दैट्स इट फॉर टुडे गाइस.